Alright guys, these are the notes for inverse functions. So today we're going to be finding the inverse of a given function. Alright, so I want you to think of inverse as the same thing that it means to undo. When you saw it in Algebra 1, usually you saw inverse as opposite, right? So here, our example here, we have 2 plus 3 equals 5. Well, the opposite would be to subtract the 3, right? To solve the equation, you would do the inverse operation. Well, the inverse operation of adding a 3 would be to subtract a 3. So then that would be 5 minus 3, and see how we still have equals to 2? Both sides are still equal. Now, the inverse operation of addition is subtraction, and vice versa. The inverse operation of multiplication is division, and vice versa. Okay, so we got to remember that from Algebra 1. So it says inverse will create a mirror image in respect to y equals x when graphing. So in your assignment and in your test at the end of this week, you would be given some graphs, and this is important. You're going to, the parent function, linear parent function will be there, and then when you graph your first function and then graph the inverse function, they will create a mirror image, and then hopefully we'll see that right now. All right. So these are the steps we have to follow. It says, step 1 to find f of -1, right? Raised to the -1. That is the notation for inverse function. So steps to find the inverse function. Step 1, replace f of x with y. Remember, they mean the same thing. Step 2, switch x and y. Step 3, solve for y. Step 4, replace y with f raised to the -1. Alright, so this is our first step. All right, now we'll look at the graph. Our first function. So this, if you were comparing them, this would be the first one you start with, and you would graph it. Your y-intercept is 3, your slope is 2, right? Then we're going to follow the steps. Step 1 is to switch the f of x with y. So step 1 done. Step 2 is switch the x and the y. So I'm going to do that in a different color. Switch the x with the y. So now it's x equals 2y plus 3. Step 3, solve for y. So this is where algebra comes in. So we want to get y by itself. We're going to have to get rid of the 3 and the 2. We're going to do the 3 first. So the inverse operation of 3, adding a 3 is subtracting a 3. What I do to one side, I do to the other. But you cannot actually subtract x by 3. So you just put them next to each other. Okay, bring down the 2y, and these canceled out, right? 3 minus 3 is 0. But I still need to get rid of the y, and it's the 2, it's touching my y. So we have to divide by 2. Divide by 2. When I divide one side, I divide the other side, but everything. Okay, so I'm going to divide it by 2. That's step 3. And if you want to simplify it so you can see the slope and the y-intercept, that would be x over 2 and minus 3/2, which is the same thing, okay? But it's easier to see your slope and your y-intercept if you do them individually, like that. All right, so that's our equation, and then we're going to change it back, and I'm going to do the step 4 over here. Step 4, change the y to f raised to that little -1 for the x. So what does it equal? It equals x over 2 minus, and if you want, and it could change to just a simple decimal, you can change that y-intercept to 1.5, just so when you see it in the graph, it makes sense. So I'm going to look at the graph here. Hopefully we can see both the equations and the graph together. So here, our original equation is in blue. Okay, that's this one right here, where your y-intercept is 3, and then you're going up 2 over 1, up 2 over 1, right? Because our slope is 2. So you put a little 1 underneath so you can follow it. And then our inverse operation is our y-intercept is 1.5. So that's negative 1.5, sorry, or minus 1.5. So that's here. Then our slope is, there's nothing in front of the x. So go ahead and put a little 1 there. Our slope is 1 over 2. So you're going up 1 over 2, up 1 over 2. If you want to use a graphing calculator to see both of them, you can actually go to Desmos online graphing calculator and graph both equations. Okay, so here you just treat this as y, and you just use the y-intercept, follow the slope. And when you look at your graph, you see that they are a mirror image on the y equals x. So this is a linear parent function, would be here in the middle. Okay, and it looks like that first blue equation was reflected over that line, and that would, now the line is on this opposite side. Now, if you want to double check that the graphs are inverses of each other, this is how you could check. And this is important because in your assignment you can do this, and in the test you can do this. You pick a point. So I'm just going to pick the easy point here, would be right where it crosses at a coordinate order pair or right on the y-intercept. So that is 3, 0. Well, then I'm going to check if this really is the inverse by switching the x and the y. So now the inverse would be 0, 3. So I'm going to check, is this point on there? 0, 3. And it is on the line. So you know that these are inverses of each other. And you can actually pick any point. Okay? And it would work. Just switch the x and the y, and if it lands on the second line that's graphed, then you did it correct. Let's do it again. Example 2. We're given f of x equals x minus 3. So first step is to change that f of x to y. Second step is to switch the x and the y. Third step is to solve for y. So if I want to start solving there, first thing I need to get rid of is that 5. So I have x equals y minus 3 all divided by 5. So I'm going to multiply this right side by 5, which will cancel out the division. But if I multiply on the right, I have to multiply on the left. So then on the left now, and I don't have a lot of space, I'm going to write it here on the side. You have 5 times x, which is just 5x, equals y minus 3. We're still not done solving. We still got to get rid of that minus 3. How? By adding a 3. That's the inverse operation. So at the very end here, put plus 3. That 5x cannot combine with the 3 because it has an x. So you just put it next to each other or at the end. These canceled out, so I'm left with y. And the last step there, step 4. Let me change colors there. Step 4. Switch the y with f of negative 1, right? The inverse function notation there. And that's 5x plus 3. So our slope is 5, and or 5 over 1 if you want to be more specific, and our y-intercept is 3. So if we have a graphing calculator or a Desmos graphing calculator, you would graph the first one, and it's this blue one. Then you would graph the second one, and it's this red one. And just to verify, you would graph y equals x, which is this black line there. Right? It's the same thing. And that will be where it is reflected over. So let's just check the point. I'm going to check this point again. That point is 3, 0. 0, 3. And then if you do the inverse or just switch them, and it won't let me write, that would be 3, 0, and 3, 0 is on there. We can actually check any point. If I want to check, we can check this point right here. Oh wait, no, not that one. That one's on the mirror one. It has to be on the red one. So I'm going to check. Oh, well, there's no other one that you can see right. Oh yeah, there's this one right here. That's negative 1, 2. So the opposite would be, -1, -2. So you switch them. So that would be -2, -1. And -2, -1 is right there. So it is on the inverse graph, or graphed line. So that's correct. Alright, next one, it says find the inverse of the relation. So this is super easy. All you gotta do is switch the x and the y. So the inverse, right, it's written like this, would be what? Well, my first point is 2, 3, so it would be 3, 2. Then my second point is 6, 8. Oops, so now it would be 8, 6. My third point is 7, 11. So now it's 11, 7. Okay? Super easy when you just get points. And also when you get a grade. Okay, that's it. Those are all our notes. If you have questions, please ask in class.